Hey everybody, my name is Garrett Yeager and today I'm going to be presenting a lesson on classifying quadrilaterals using a hierarchical system. So in order to do this, first we have to understand what a quadrilateral is. A quadrilateral is a two-dimensional shape with four sides, and it's also a closed shape. And there's several types of quadrilaterals, and a big problem that a lot of people have when they try to distinguish among these is that a lot of quadrilaterals all have the same properties at a basic level, like having four sides, or having congruent sides, or having parallel sides. So it's important that we understand kind of this pyramid of where all of these different forms of quadrilaterals fall. And at the top of this pyramid, we have quadrilaterals, which is just a four-sided closed figure. And then on one side of this pyramid, we have trapezoids. And trapezoids are quadrilateral with one set of parallel sides. On another side, we kind of have what I consider a misfit, which is kites. And are a quadrilateral with no parallel sides. And then we have parallelograms. Parallelograms are any quadrilateral with opposite sides that are parallel. So this top side and this bottom side would be parallel, and both of the sides would be parallel. And then we have rectangles, and rectangles are a parallelogram with opposite sides parallel and four 90-degree angles. So rectangles are a subset of parallelograms, which means that they would be below them on our pyramid or our hierarchical system. And then we have rhombuses right next to rectangles, which are also a parallelogram and have opposite sides that are parallel, and they have four congruent sides. And what I mean by four congruent sides is that all four sides, if you were to measure them, would be equal. And then we have a subset of both rectangles and rhombuses, which is a square. And a square is a parallelogram with four equal sides, four 90-degree interior angles, and opposite sides that are parallel. So a square is a parallelogram, a rhombus, and a rectangle all tied into one. And we can kind of see this flow chart describes a hierarchical system of quadrilaterals. At the top, we have quadrilaterals, which is just any closed four-sided figure. And we have trapezoids. In this image, this is an isosceles trapezoid, but it could also be a scalene trapezoid in which these two sides wouldn't be congruent, but we still have to have two sides that are parallel. And then we have our parallelograms, and here you can see this side and this side are parallel, and this top and bottom are also parallel. And over here is our misfit, the kite. Just what you're thinking about, like the regular shaped kite that you fly on a string on a windy day. And you can see here that none of these sides are parallel to each other. And as subsets of parallelograms, we have rectangles and rhombuses. The rectangle you can see has all four sides that are parallel, and if I were to take a protractor and measure all of these interior angles here, I would see that they are all 90 degrees. And then rhombuses, you can see that all four sides are also parallel, but if you were to take a protractor, these sides wouldn't be 90, but they could be on some cases. In this example, they aren't. And rhombuses also have congruent sides all the way around. If I were to take and measure this side, and this side, they would all be the same length. And then a subset of both of these, as well as a subset of parallelograms, is a square. A square has all four sides that are congruent, which is the same measure, and all of their interior angles are 90 degrees, as well as all four sides are parallel to their opposite. And a big issue that a lot of people have when they're trying to identify these is the difference between rectangles, squares, and rhombuses, because they're all parallelograms. They all have opposite parallel sides, so why aren't they all the same? Well, while they all have very similar properties, and they all have parallel opposite sides, they can be distinguished by three simple questions. The first question would be, are all the sides congruent, or are they the same length? If yes, then this shape is a rhombus. And if no, then this shape is a rectangle, meaning that the sides of the width might be longer than the height, or vice versa. And the second question is, are all four interior angles 90 degrees with only opposite sides congruent? If yes, then this shape is a rectangle. And then we also have, are all four sides congruent and all four interior angles 90 degrees? If this answer is yes, then this shape is a square. And a cool way that you can think about the similarities between a square and a rectangle and a square and a rhombus is here we have a square. And if we were to just take and just stretch these two sides, we would end up with a rectangle. We would still have four 90-degree angles and we'd have parallel opposite sides, but our four side lengths would not be congruent to each other. And how we get a square from a rhombus or a rhombus from a square is if we have our square right here and we were to take these two corners and pinch them together to where they're closer than these two corners, then we would end up with a rhombus. But if we were to take and pull those out to where they're all the same distance from each other and all of the angles inside are 90 degrees, then we have a square.